folks, to another exciting JLAM Bio exclusive. I know you are just as pumped as I am to talk about chemical reactions and balancing. So again, I know we've covered a lot of this information last year. We're going to go a little bit more in depth, talk about some more complex chemical equations to go through and balance. And then we'll also talk about different reaction types, probably a little bit in a later video. So let's check out our goals and go ahead and get started. So hopefully by the end of this video, you should be able to identify different chemical reaction types. You should also be able to balance chemical equations and explain how different chemical reactions are represented. Now, we're not going to get into the huge detail of all of the different specific types of reactions, but at least get a little bit of an understanding of what those are. Balancing is very important to follow the law of conservation of mass, and explaining how those reactions are represented helps us get a better understanding of what's going on when we actually take a look at those representations of chemical reactions. Let's get started. Really simple vocab. Yeah. So chemical reactions are when one or more substances are converted into new substances through the breaking and forming of new bonds. So if you take a look at the example on the right here, we have methane, CH4, that is reacting with oxygen. The covalent bonds between the methane and the oxygens are broken and then reformed to form new chemicals that are more stable. And what we have here are two molecules of water and one molecule of carbon dioxide. Remember that this is very different from just a physical change where we are changing the shape, we're changing the state of something, but no chemical bonds are actually broken. We call the starting materials our reactants, and we call the ending materials our products. Now, when we look at chemical equations, they are simply representations of reactions, their symbols, and chemical formulas. So if you take a look here, we have several different states of matter, including G for gas, L for liquid, S for solid. Remember that AQ is aqueous. That means that the material is dissolved in water. We have our chemical formulas, which are represented by the letters that represent the elements that are on the periodic table. We have our subscripts, which are determined from our nomenclature rules. And then in order to balance the chemical equation, we actually have to put coefficients in front of it. Remember, the amount of materials that you start with in your reactants must be the same as the material in your products in a normal chemical equation. Remember that it always takes energy to break a chemical bond. So in order to break the bonds between the chemicals down below, you have to add energy into it. That energy forces that bond to break, and thus the atoms become less stable. Conversely, we actually remove energy when we make chemical bonds. We remove that energy, which allows the molecules to become more stable by forming those bonds. So it takes energy to break a chemical bond, and it releases energy when a bond is formed every single time. Now, when we talk about balancing chemical equations, we must make sure that we observe the law of conservation of mass. And that simply states that the number of atoms of the reactants must be the same as the products. So with the normal equation, where we don't have the 5, the 4, or the 3 that you see there to the right, it would be unbalanced. You'd have 3 carbons to the left and 1 to the right. You'd have 8 to the left and 2 to the right. And you'd have 2 oxygens and 3 oxygens. So we actually add coefficients. We add numbers in front of the chemical species, and we do that in order to balance the number of atoms. So by putting a 5 in front of O2, a 4 in front of H2O, and a 3 in front of CO2, we end up getting the correct number of atoms on both sides of the equation. So we'll start off with some simple ones and get to some more complicated ones a little bit later on as we go through the unit. But for right here, let's add coefficients to balance the following chemical equations. So the way I start, I always look to see what's different. We've got F's that are different, so 2 F's to the left, 1 to the right. In order to balance that out, we have to put a 2 in front of NaF. Now we have 2 F's on the left and 2 F's on the right. Now I have 2 NAs on the right. I changed that, so I'm going to go to the left side and put a 2 in front of NaBr. Again, that makes those 2 NAs balanced. Now I have 2 Brs on the left, 2 on the right, 1 Ca on the left, 1 on the right. My equation is balanced. Pretty straightforward there. If we take a look at the bottom here, a little bit more complex. What you'll find is that when you have a reaction that is combustion, which is this because we're reacting it with oxygen to produce carbon dioxide and water, we'll talk a little bit more about that in our next video. You always go carbon, then hydrogen, then oxygen, in that order. I have 3 carbons to the left, 1 to the right, put a 3 in front. 8 hydrogens to the left, 2 to the right, 4 in front. If I count up the total number of oxygens, I get 6 there and 4 there. So I have 10 total oxygens, so I need a 5 in front of that. All right, pretty straightforward. Be sure to be careful when you're counting the number of atoms in, let's say, polyatomic ions. So for example, if I had something like this, let's have 3Ca2, 3Ca3, PO4, 2. Okay. Distributive property applies here. So in this case, I have 9 CAs and 6 PO4s. Okay? So make sure that you're aware of that this and this help you determine how many of each individual ion or polyatomic ion are present. Let's move on. Just some easy, simple to remember tips for balancing. Work your way from one part of the equation to the other. So if you paid attention to when I was doing the practice problem, we start off with one thing that's different, and then we change something on the opposite side. That thing that you changed then needs to be rebalanced on the opposite side, and you kind of work back and forth in order to balance the whole chemical equation. Try to keep your polyatomic ions together if possible. So for example, if there's a sulfate ion on the left side and a sulfate ion on the right side, you want to keep those together because it makes it a lot easier to balance those than just having sulfur and oxygen separate from one another. Water can be broken down into H and OH for easier balancing. So in some cases, you'll have an acid-base reaction where you'll see hydroxide on one side and a hydrogen atom on the same side, and then it becomes water. Well, if you break water down into H and OH, and HOH, same as water, it becomes much easier to balance that equation. And if you need extra help, draw a T-table and count each atom. Some people get this relatively quickly. Some people tend to struggle with being able to visualize this. If you're one of those people that struggle, count each atom out. It's okay. There's no penalty for doing that. All right, guys, pretty straightforward here on balancing chemical equations and what chemical equations are. Take your time, read through those chemical equations very carefully, balance them out properly, and we will see you guys next time. Have a great day, guys. We will talk to you later. JLand Bio, signing out. Goodbye.